Hey everybody, it's Miss Williams, and today we're going to talk about completing the square. We've already done a little bit of this in class, so this is just to help you with the back side of the worksheet that is due the next class period. Okay, this is the fourth video in our quadratics unit. So, how do we convert from standard form to vertex form? And why do we even need it? Vertex form allows us to see the vertex of a quadratic in the equation. Now remember, the vertex is either the maximum or the minimum point. Okay? Vertex form is y equals x minus h squared plus k, where the letter in the number in the h spot and the number in the k spot is actually your vertex. Okay? Standard form, if you remember, is y equals x squared plus bx plus c. So what we want to do is we want to be able to take it in standard form and make it in vertex form so that we can see what the vertex is in the equation. How are standard form and vertex form related? Well, if a standard form is a perfect squared form, then x squared plus bx plus, so if you take that middle number that's on the x, and if you divide it by 2 and square it, that will make your standard form a perfect square. And then x, to find it in vertex form, you would say x plus b over 2 squared. So we've already done this on the first 3 pages of the worksheet. Alright, so we've already discussed this and talked about this, so this should kind of come back to you a little bit. Alright, so now we're actually going to solve a quadratic by completing the square. So there are steps that you have to take. So when you solve it, remember, we're not just completing the square now and changing the form, we're going to actually solve it. We're going to get x equals and x equals. This is going to be the roots, so where the graph is going to actually cross the x-axis. Right? So the first thing you're going to have to do is move the constant to the other side, complete the square by adding a constant to both sides, rewrite the left side in a binomial squared, and simplify the right side, and then square root both sides, and finally solve for x. So I'm going to work through one of these, and these are actually the examples on the back side of the worksheet that you're going to need to have for next time. All right? Whoa, let me go back. So we're going to start with x squared plus 4x minus 21 is equal to 0, and our first step is to move the constant to the other side. So I'm going to add 21 to both sides. Okay. The next thing I have to do is complete the square by adding a constant to both sides. So just like in class, we did x squared plus 4x plus something is equal to 21 plus something. Alright, so where did I get these 4's from? Well, I took 4, that's with the x, divide it by 2 and square it. 4 divided by 2 is 2, 2 squared is 4. So since it's a balancing act, I'm going to have to add 4 to both sides of my equation. Alright, now the left side is a perfect binomial, so that's been squared. So I can rewrite the left side of a binomial squared and simplify the right side. So this gives me x plus 2 squared, and then 21 plus 4 is 25. Now I'm going to square root both sides. When you square root, it goes away. So that leaves me with x plus 2 on the left side. And then remember, when you square root 25, you don't just get 5, you get positive and negative 5. Because 5 times 5 is 25, and negative 5 times negative 5 is 25. My final step is to solve both for x. So I ended up, remember, this is really 2 problems. This is x plus 2 equals positive 5, and x plus 2 equals negative 5. So I'm going to subtract 2 from both sides of my first equation and get x equals 3. Subtract 2 from both sides of my second equation, and I end up with x equals negative 7. Okay. There are 5 additional problems that you need to do on the back side of the worksheet, so make sure you've completed those before you come to class next time.